Let's derive the law of sines by essentially abusing the formula for the area of a triangle. So let's say that this was my triangle ABC, and I'm trying to find the area of this triangle, which I'll denote like that. You and me know that the area of a triangle is 1/2 times base, which happens to be just the variable b here, times our height. But let's not write our height like this. Let's actually take this opportunity to introduce a sign. So I'm going to focus on this triangle right here and solve for that h1. So let's say sine of angle A. Sine is going to be opposite over hypotenuse. Opposite of A is h1, hypotenuse is c. So sine of A is going to be h1 over c. And if we solve for height by just multiplying by c on both sides, we're going to get that our height in this triangle is equal to c times sine of A. All right, so our area is going to be 1/2 base, which is b, times our height, which we just said was c times sine of A. Okay, what if we took the same exact triangle, but took this to be the height instead? I'm going to focus on this triangle right here to rewrite my h2 the same exact way. And now I've got another equivalent way to express our area. It's going to be 1/2 times our base relative to our height here, so our base is going to be c, times our height, which we just said was A times sine of B. And in the same exact manner, we can find the area to this triangle by saying that this is the height. All right, we've got 3 equivalent expressions for area. I think it's just going to take a few steps of algebra to get it to look like the law of sines we know and love. Why don't we multiply through by 2? And then I think the last thing we got to do to get from here to looking like that is to divide each side by A, B, C, which is not going to be 0, right? Because these are sides of a triangle. A triangle is not going to have a side of 0. And there she is, the law of sines. So this really isn't that bad. It's just finding 3 equivalent expressions for the area of a triangle, not using h1, h2, and h3, but rather using these expressions that conveniently introduce signs. Once you have those area expressions, doing some manipulations and getting our beautiful law of sines. Voila.